Good evening, ma'am. Yes, you're audible.
All right. So Rabia, Humam, Tarif, Faiza, Austin, all have joined. All right. So in the last class, we had completed superposition principle. I think you had the assessment also. So superposition principle was over. Now we start with dipole moment. Now see class, tell me one thing. I'll take a test of yours, subjective written test on Monday till dipole moment, till whatever I complete in today's class. All right. Now, just tell me one thing. How do you all want the revision to occur? Like, I have completed till here. Suppose in today's class, obviously, it's difficult to complete the entire dipole moment, but let's assume we have completed till this part. So, you want me to take a class and revise all this part, or you want me that once the entire chapter is done, then revision? Just let me know in the chat column how all you want the revision, because our syllabus is going at good pace. And do not worry about the syllabus. When you will be having the summer vacations also in your school, here you will be continuously having classes. So whatever syllabus will be completed on time. Last year's batch also syllabus got completed in the month of November only, and we had 2 to 3 months of revision. So do not worry about the syllabus. So that's why I'm saying how do you all want to go about? I'll take a test on Monday. I'll analyze whatever how you all are performing. But apart from that, also I want revision to occur. Whether you're performing good or bad, at least we should have an idea of what all topics we have studied. So you want in between, we should have one revision class, and then when the chapter ends, revision of all these topics, or you want that revision to entirely together. Just let me know in the chat box column quickly, class. Half chapter is done after completing the lesson, entire chapter. Okay, so it's half of you want there and half of you want it there. One student hasn't given any response. Rabia has, Tarif has, Humam has, Austin has. Yes, Faiza. Faiza revision after half. Okay. Let's do one thing. Let's see. Then let's first you people give the test on Monday, subjective written test. Then according to your performance, let's analyze. Okay, let's start with dipole, at least introductory part. Otherwise, here Maghrib time will start and I'll have to leave them. And class, this trouble is for the month of Ramzan only. Once this is over, after Eid, the classes that we'll be having, you won't be getting any interruption right now because of the timing difference. That's why we have this clashing. So that's why I'm saying, do not worry about the syllabus also, and do not worry about this break that I have to leave in between. Just 2 to 4 classes, I think more, then we'll be having smooth classes. And in your summer vacation also, I'm repeating, you'll be having continuous classes here also. Extra classes also I'll take in your summer vacation. So all your syllabus will be tallying up. Now see, monopole means what? Monopole is system of one type of charge. Don't look here by the definitions. These are just written so that you can copy it later on. If I give you electron, is it needing any other entity to be dependent upon? No. Electron is itself a self-completely sufficient elementary particle. Then we have proton. Proton is also an elementary particle itself. So it is not depending upon other quantity to define itself, right? So these are monopole. Mono means single, pole means polarity, that either positive or negative. One positive and other one negative, like this. So that is monopole. So one we have monopole moment. Monopole moment means net charge. Monopole moment basically means, this means net charge. Net charge means, suppose if I say, let's take an example. If I say in this particular part, I have 2 coulomb plus 3 coulomb. So monopole moment will become plus 2 plus 3 coulomb, that is plus 5 coulomb. Simple additive property of charges that we have studied. All right. So additive properties of charges that we have studied, that is applied here. So monopole moment. Now, once we have 2 equal and opposite charges, fine, 2 equal and opposite charges with separation between them. If I say plus Q and I give you minus Q, So plus, positive, negative together with, let's say, certain separation between them. They are separated by this distance 2a, for example. All right. Or I say, one example is this. If I say, let's say from your chemistry, let's take example. H plus separation from Cl minus. So plus charge and negative charge together. This is not independent. H plus not separately. H plus we know that is proton, and chlorine ion also we know that is negative independent isolated ion. No, but HCl molecule we have, hydrochloric acid, you must have heard of, studied. So same thing. If let's take about normal common salt, NaCl. So it's actually sodium Na plus Cl minus. They are separated by some distance, some very small separation in angstrom, nanometers they are given. So these are what? These are known as dipoles, set of positive and negative charge, but the condition is that they should have the same magnitude. If I say, for example, if I say plus 2 microcoulomb, then minus 3 microcoulomb won't make my dipole. For plus 2 microcoulomb, I have to have here minus 2 microcoulomb only, separated by certain separation. This is what is meant by dipole. All right. So I'm repeating definition so that you can write. System having only one type of charge, either positive, negative, is monopole. Net charge, net resultant of all these monopoles, it gives us monopole moment. Then you have dipole, system having equal amount of positive and negative charges at a small separation between them, like HCl, NaCl. And what is dipole moment, that I'll discuss with you. Dipole moment I'll discuss in detail. Just note it down. I'll ask someone to scroll it out. So I have to leave class right now. After 10 minutes, I'll join you back. Note down all these till the time. Yes, class. So what we were discussing, yes. So monopole is what? Monopole is single charge present, right? One single charge present. Monopole moment is net charge moment. That is the net charge that is present. You can add it, subtract. If had there been -1, you would have subtracted -1. Dipole is positive and negative charges separated from a certain distance, separated by a certain separation. So you must have written till here, I hope, all of you. Now dipole moment. That was just the introductory part. Dipole moment is of importance to you. Dipole moment basically tells the strength about the dipole. So how to write the dipole moment? These things you can write it later on. Just see. This is one charge plus Q. This is another charge minus Q, right? They have a separation. It's always plus Q and minus Q, not Q1 and Q2. Charges are not different. They're just signs are different. 3 coulomb to 3 coulomb. Here also, there also, -3 and +3. It cannot be +3 and -4, right? And it can also not be -3 and -3. Both have to be same magnitude, and one has to be positive, one has to be negative. Let's say their separation is 2a. So how to calculate the dipole moment? Formula is very easy, class. This is the easiest formula. We represent dipole moment through this P. Take the magnitude of any of the charges, let's say Q, and multiplied by the separation between them, 2a. That's it. That's it, class. This is the formula of it. So if the separation is 3 centimeters, let's say, separation between them is 3 centimeters. So your 2a will be 3 centimeter. Do not double it by seeing this 2. 2a is just, it's just that by convention, we are in a habit of writing 2a. It's by convention, the formula is set. It could have been a, then it would have been simpler for you. But here we do not write anything. We just write 2a. 2a means the separation between them. Never double it, class. All right. If only half is given, only a is given, then double it to find the separation between them. This part will be a, this part will be a. The entire we take it as 2a. So it's a vector quantity. This is also a vector quantity. So if it's a vector quantity, magnitude, you will get it from here. But what about the direction? So direction is, see, dipole moment you have in chemistry also, but in chemistry we move towards the electronegative element. In physics it's opposite. Direction is from the negative charge to the positive charge. This is the direction of dipole. This is a very basic quantity, but till your EM waves, that is till your first book, entire first book, you will be using dipole. So it's better if you learn it properly. It's a very easy thing, but you will see now we will be seeing this is it all about dipole moment. That's it. But you will see now how electric field applies dipole, how in torque you have dipole moment, how in electric flux you have dipole moment, in potential you have dipole moment, in capacitance you have dipole moment. So it's a very small quantity, but it has a greater significance. Now SI unit, class. See, charge is SI unit. What is the SI unit of electric charge?
Coulomb.
Coulomb, right? So this will be coulomb. And what is this SI unit for distance?
Meter.
Meter. So only Faiza knows this. Coulomb meter. This is the SI unit. Fine. So it's a vector quantity, magnitude of any separation. For example, no, a very easy example let's take. Let's say this charge is +2 coulomb. This is -2 coulomb, and their separation is 3 meters, let's say. Or 3 meters, let's say the separation is 3 meters. So how to write the dipole moment? Take any of the charge. So 2 multiplied by the separation 3, 6 coulomb meter. That's it. This is how you write it. But one good question we'll see on this. First, note it down. Then I'll give one question we'll practice. I hope you've completed till here, all of you. If anyone is writing, just stop me. Otherwise, I'm scrolling. Now see, this is a question. You have to calculate the dipole moment. You will try it by yourself first, then I'll discuss the solution. Whatever answers you're getting, whatever, send me. So this is charge 1 located. This is charge 2. They are forming dipole plus minus. Separation between them is there. Tell me the dipole moment. one charge is given as minus 2 millicoulomb, and another charge is given as plus 2 millicoulomb. So formula of dipole moment is charge, magnitude of charge multiplied by magnitude of separation between them. Now see, charge is 2 millicoulomb. So that becomes 2 into 10 to the power minus 3 coulomb. How will you convert milli? 1 millimeter is equal to 10 to the power minus 3 coulombs. So this is how, this is the charge that is present. Now what is 2A? Everyone reply me in the chat box. Which value should we take for 2A? Charge is this, 2 millicoulomb. What should we write for 2A? All of you respond me in the chat box. Otherwise, I'll call out names and I'll ask you to answer. So yes, Austin and Faiza, you're right. See, Tharif, if you take 2 millimeter is separation till this point O. Plus Q and minus Q. These are the charges present here. We take the separation between them. If you take only 2 millimeter, it will be separation between this charge and this point O. The entire separation is 2 millimeters plus 2 millimeters. That is 4 millimeters. This entire separation. This is 4 millimeters. So we'll also take 2A as 4 mm. So 4 into 10 to the power minus 3 meters. So dipole moment will be 2 into 10 to the power minus 3. This will be 4 into 10 to the power minus 3. So dipole moment, this will become 8 into 10 to the power minus 6. Now see, distance, if we take the direction if we take from positive charge towards the negative, from negative charge towards the positive charge. So this is the negative charge. If you move towards the positive charge, this is plus z, this is minus z. So which unit vector we'll write for plus z axis? That is k cap. So this much k cap coulomb meter. This is the complete answer to it. See, for the unit vectors, for x-axis, it's I cap. So plus I cap for positive x-axis, minus I cap for negative. Similarly, y-axis has j cap. So plus j cap for positive and minus j cap for negative. Then z-axis, this is k cap. So plus k cap for positive, minus k cap for negative. Note down the solution. All right, class. Now see electric field on axial line of dipole. So if this is the dipole and we have to find out electric field on its axis. On its axis means if this is the axis. So electric field on any point here. This is point P. The separation between the charges, this is 2A. Now electric field will be present because of this positive charge also and this negative charge also. So if you draw electric field on this point because of this positive charge, it will move away. This will be electric field due to positive charge. And for negative charge, we have studied that electric field move towards the charge. So electric field will move towards the charge. This will be E minus Q. So we'll have both the electric fields, E plus Q and minus Q. Now let's say separation from the center to this point. Let's say this is R. Separation from the center of dipole to the point of calculation, this is R. So you have two electric fields. One is E plus Q and another one is E minus Q. Fine. Now see, we'll write the magnitude of E minus Q. This will be, how do we write the formula? We use the formula KQ by R square. Here also we'll use the same. So for negative charge, we are calculating electric field due to this negative charge minus Q on this point P. So electric field will be K, charge will be Q. We will take the magnitude, so negative sign we'll ignore. Separation. What is this entire separation? See, till here it is 2A. Till here the separation is 2A only. And till here, this is from here, see, from point P to this point. Let's name this point something. Let's say this is O. PO is R. This part is A and this part is A. So can any of you tell me how much is this entire separation? Let's say AB. How much is AP? OP is R. AO is A. So how much will be AP, this entire? Yes, class. See, this is R. R plus A. Yes, Austin. Right. This is going to be entire will be R plus A. Till here this is R and this additional part is A. So this becomes R plus A whole square. And what will be the direction? Direction is towards left. Same thing if we write for E positive. Same thing if we write for E plus Q. This will be KQ divided by, now see, this entire part, this is R and we want BP. If entire is R, OB, this part is A. How much will be this left out part? This entire is R. This part is OB. So how much will be this part left? R minus A. Good, Faiz. This will be R minus A whole square. Towards right. Now net electric field, resultant electric field at this point P. This will be electric field due to plus Q plus electric field due to minus Q. This principle we have studied yesterday. This is superposition principle. So electric field on the axial line. This will be KQ by R minus A whole square minus KQ by R plus A whole square. Because they are in the opposite direction, that's why we are subtracting it. Now see, we can take KQ common. If we take KQ common, From here 1 by r minus a whole square minus 1 by r plus a whole square. This will be left. Now what we can do, we can take the LCM. Let's take KQ as common only. So r plus a whole square here minus r minus a whole square divided by r minus a into r plus a, their square. Just taking the LCM. This is how you take the LCM. No, you multiply this term here, you multiply this term here, multiply them within themselves. So see, KQ is common. We'll open it. R square, a plus b whole square identity we'll use. So a square plus b square plus 2ab minus. So minus r square minus a square again plus 2ra divided by. This becomes C class. Identity is a square minus b square is equal to a plus b into a minus b. So this is r minus a whole square is 1 and r plus a is 1. So a minus b into a plus b. So this becomes r square minus a square but with a square because since there is square here also. And C, r square gets cancelled, a square gets cancelled. So we are left with this is equal to KQ into 4AR divided by R square minus A square to the power whole square. Now one thing class, 4A, can I write this 4 as 2 into 2, right? 4 can be written as 2 multiplied by 2. So I can write KQ into 2R separately. And this 2A here. So 2 into 2, 4. A, R, KQ. Same things. Divided by R square minus A square whole square. See, I'll write Q also here. KR here. K2R here with Q here. Now see, why I have just rearranged it? Because K into 2Q, this will give me dipole moment. K into 2Q, this will give me dipole moment. This is going to give me dipole moment, right? So what will be the formula for E axial? It's going to be 2, this K, this is going to be P, this R divided by R square minus A square to the power whole square. This is the formula for it. You can write it as K as 1 over 4 pi epsilon naught also, which is 9 into 10 to the power. Now see, on the axial line, always remember direction of field is same as that of dipole moment. This means what? This means that, see, if this is plus Q, this is minus Q, and the dipole's direction will be from negative to positive. From negative to positive, that is towards right. So electric field's direction will also be towards right. If this is towards left, somehow electric field's direction will also be towards left. For which case? For only axial case. Now we just simplify this formula. If we take no ideal dipole approximation, in ideal dipole approximation, we assume that the separation between this plus Q and minus Q, this is very small. This A is very small. A, this separation half A that we get, this is very, very small in comparison to the point that we are calculating. R is greater, A is small. So if R is very much greater than A, R square minus A square will almost be equal to R square class. See, it's like R square, it's a big number. Let's say 1000. And A square is a very small number. So let's say you've squared it and you're getting 1. If you subtract 1000 minus 1, you will get 999. And 999 is almost equal to 1000. So if I write 1000 or 999. I can replace this 999 with 1000. So from a very big thing, if I subtract a very small thing, I'll almost get the very big thing back. So r square minus a square will almost be equal to r square only. So in the formula, E is equal to 2kpr by r square minus a square whole square. Instead of this whole term, this term, r square minus a square, I'll just put r square instead of this term. So that will be 2k pr by, instead of this term, I'll put r square, and this square is already here. So what is the formula for axial? 2k pr by r to the power 4. This r gets cancelled. Electric field on an axial line after ideal dipole approximation, this is 2kp divided by rq. Fine. From here you can see electric field is inversely proportional to rq. So this is the formula, but this is the formula. When can you use this formula? Only when this is valid. R is very much greater than A. Otherwise, you have to use this formula. This is the derivation class. This derivation noted down. You have to write this derivation in your exam. This derivation is asked. Noted down, entire derivation can come. I think this is the first detailed derivation of your class 12. Done. Okay, now electric field on equatorial line of dipole. So this means if this is minus q and this is plus q, and a point perpendicular to it, if I'm asking you, if I give you this point, this would be axial. If I give you a point anywhere here, that will be perpendicular to it, right? This will be perpendicular to it. So this point is known as lying on axial point. When we say this is the point that is lying on the axis of equatorial point. Now see, if we write the electric field due to this positive charge, electric field due to this positive charge, it will move away. This will be electric field due to plus q. Due to this charge, plus q, it will move away. And because of this negative charge, it will move towards it like this. And the separation again between them is 2a. So this is E plus q, this is E minus q. Let's say this is some angle theta. So if this is theta, and if I draw a line parallel to this is theta, this will also be theta, this will also be theta. Why? Alternate angles. Now see, let's resolve this. This becomes E plus q cos theta, and perpendicular one will give E plus q sin theta. Same way, if we resolve this minus q also, here we'll get E minus q cos theta, and perpendicularly we'll have E minus q sin theta. Fine, this is how we have resolved it. Also, if this part is A, this is R. We take the point, let's say this is point P. So we take the separation of point P from the center, that is R. What will be this? It's like this is A, this is R. So this is going to be under root R square plus A square using your Pythagoras theorem, right? Under root R square plus A square. Also, this angle is theta. So cos theta is going to be base by hypotenuse. Base is A, hypotenuse is under root R square plus A square. This is all what we need. Now, let's see the derivation part, the calculation part of it. See, electric field due to this negative charge, E minus Q. This is going to be KQ divided by R square. Now, what is the separation between Q and point P? They are separated by this distance, under root R square plus A square. So we'll write under root R square plus A square whole square. This is E minus Q, which is KQ divided by R square plus A square. Same way for E plus Q also, we'll have KQ divided by R square plus A square. Because same thing, no, magnitude is same. Look here, under root R square plus A square. For this side of the triangle also, this is A, this is R. So this side also is going to be R square plus A square. Clearly here, this is E plus Q and E minus Q. Now see, do you notice this? Sine theta and sine theta, they are in opposite direction. They are cancelling each other exactly. See, magnitude is also same, E plus Q. This magnitude is also same, E minus Q. Sine theta, sine theta. It's like plus 5 above and 5 below. So 5 cancels each other. So net field along y-axis will be nothing. See, net field along y-axis, EY, this will be E plus Q sine theta minus E minus Q sine theta. See, both the magnitudes are same. You can cancel each other. This is 0. So E plus Q sine theta has cancelled this downwards. E minus q sine theta. But net field along x-axis is still left. Net field along x-axis. Look here, this is E plus cos theta and E plus cos theta. They are in the same direction, so we'll add it up. So Ex will be E cos theta, E plus Q, plus E plus Q cos theta. So this will be 2E cos theta. Ex will be 2E cos theta. Now let's write the values. 2. Electric field we have just calculated. Both of them have the same magnitude, that is K Q divided by R square plus A square. And cos theta also we have calculated. What was cos theta? From here, this is the value of cos theta, A by under root R square plus A square. So A by under root R square plus A square. Again, class, one thing. If we write this together, or let me write it here only. If I write this together, K Q 2A. I have just rearranged it, divided by. See, this term is, it's like R square plus A square to the power 1 multiplied by R square plus A square to the power half. Root, you can write it as half. So that becomes R square plus A square to the power 3 by 2. So R square plus A square to the power 3 by 2. How? This is 1, this is half. Half plus 1, 3 by 2. And what is Q into 2A? Yes, what is Q into 2A?
P, ma'am.
P, that is dipole moment. This is P. So you have your formula again. Electric field due to equatorial line will be K P by R square plus A square to the power 3 by 2. This is the formula of electric field due to equatorial line. But now electric field will be opposite. If your dipole is moving towards the right, let's say in this example, this is moving towards left, minus 2 plus. So electric field will move in the opposite direction. Same was for axial, opposite for equatorial. See in this example, this is dipole is moving from negative to positive. Dipole is moving towards right. Electric field will be towards left. Just exact the opposite direction. Now here also you can apply ideal dipole approximation. If you apply ideal dipole approximation, so here also R will be greater than A. So R square plus A square will be almost equal to R square. It's the same thing, no? If we add 1000, a very big quantity, plus a very small quantity, let's say 1, that will be 1001. We can write 1001 approximately equal to 1000 only. So E will be Kp divided by R square to the power 3 by 2. This half gets cancelled. So electric field on equatorial line becomes Kp by R cube, where this K is 1 over 4 pi epsilon naught, and electric field is inversely proportional to R cube. Just a summary of what we have studied. See, in axial line, after dipole approximation, it was 2 Kp by R cube. Equatorial line is minus Kp by R cube. Direction is same as that of dipole in an axial line. Direction is opposite to that of equatorial in dipole moment in equatorial line. And if you take the ratio of axial line and equatorial line, you will see axial line is twice that of equatorial line. You were getting 2 Kp by R cube in axial, and here in equatorial, you are getting Kp by R cube. So E axial is actually twice of the equatorial. This is just a summary. We'll see this again later on. But first, see, this is the formula when ideal dipole approximation is not used. R and A, they are similar. There is no distance gap between them. So this is the formula for it. Learn the formulas. And once you see R and AR, they have a quite difference between them. E is equal to Kp by R cube you are going to use. So these two derivations, these are lengthy derivations, but these are very important from your board examination perspective. Derivations have a quite weightage in your exam. So from your this chapter, from especially from electric field and this lesson, these two derivations are very important. Other than this, you have certain very short derivations of Gauss theorem that you will be able to manage. But these derivations, these are lengthy derivations and they require your attention as well. Note it down. Any doubts, let me know. And note it from here, I'll scroll it. Done, class? Just text done in the chat column once you have written. And what about others apart from Faiza and Tarif? Rabia has also completed. Austin, what about you? Humam? All right, done, no? So all of you have completed. All right, no, we'll start from here only. This is entire part of electric field due to axial line also, and electric field due to equatorial point also. So dipole moment we have completed. What is the formula of dipole moment? Basically, you have to take the charge and whatever is the separation between both the charges. Just identification of dipole moment is important in the sense both the charges cannot be same, as in their magnitude has to be same, but their signs have to be opposite with a small separation between them. That's what we have studied. So the contrasting factors, this point we'll start from here, the contrasting points between them, and questions also we'll see it in the next class. But before that, just have a look at your questions which you have to practice. So from your electric dipole in uniform electric field, so we have completed the entire dipole moment. So question 1, 2, 3, 4. All these 4 questions you have to complete from electric dipole and uniform electric field. These are just level 1 CBSE pattern. We have studied it. You should be able to do it. You can leave this. Do not do one question because it involves torque. No. So do second, or this also you can. Torque basic definition you all know. 1, 2, 3, 4 at least try, because in the next class we have to catch up from here only. Till this 4th question you have to do. No need to go into the level 2 of NEET, just these 4 questions from CBSE. All right, so now I think your assessment will begin. So same topic what we have completed, dipole moment. Revise it. In the next class, I'll take your subjective test as I have mentioned you already. And what all syllabus will come? Electric charge, Coulomb's law, electric field, and dipole moment. Whatever from the day 1 which we have